All right, guys, I'm going to create this video. I'm going to add a little bit more into the transformation piece that I talked about before. I forgot to talk about whether something is going to be expanded or something is going to be compressed. When we talk about expansion, that means we're taking our function and outside the parentheses, we're going to be multiplying by a fraction or dividing it out, right? So it gets wider as it goes. If we're talking about f of x is x squared, we're going to say that here's what the function looks like. It's that parabola, right? If we say that f of x is x squared, or f of x, or g of x, pardon me, g of x is 1/4 x squared. 1/4 x squared would be way out here and nice and flat. Okay, and it would look like something like that. So that's one sort of dilation. If we say g of x is multiplied, outside this a here is multiplication, then this happens. It gets very, very narrow and steep. And when we talk about that, it's expanded, right? When we take something that's if a is greater than 1, we expand it, so we stretch it way up. But if it's compressed, right? We've taken this dot here and we've stretched it up, we've expanded it up. If we look at this point here on the parent function, and then we go up here on the new function, we look at 1, we've expanded that way up here, right? We've stretched it way up. Well, here 1 has been pushed down right here. It's been compressed down toward the x-axis. And so this is the same idea, right? The same kind of thing happens if it's compressed horizontally. If a is greater than 1, then we're going to talk about this being compressed horizontally. Horizontally means it's going to be pushed in, right? Well, it looks virtually the same. We have this, but if we take a point here, right, and we talk about it horizontally, well, that thing that was stretched when you multiplied by something greater than 1, right? This value, horizontally speaking, gets pushed in toward the y-axis. That's the y-axis. And then if we talk about how it happens to stretch or expand when we're talking about along something less than 1, and this is like 1/4, we've expanded it out this way, we've sent it out that way along the x-axis, right? So if we're talking about where it is horizontally speaking, we've pushed it way out. All right, so they look the same, but we can talk about them in different ways and where they are on in terms of what they look like compared to their graphs, their parent graphs. I'm going to go ahead and move this just a little bit so I can show you on the study guide what these bad boys look like. Okay? Let's look at this parent function. This is kind of cool. We have to choose what the parent function was, right? It says identify the parent function. and then describe what has happened and then draw it. Well, I'm going to go ahead and draw the parent function because I like to draw the parent function first. The cool thing about this is the parent function is f of x is the absolute value of x. So we know that function. We know that that goes like this, goes like this. That isn't perfect, right? And then, well, what's happening? Well, this is inside the parentheses. So this is going to be shifted over to the left 4 spaces. So if I take my new marker and make g of x green, right, I'm going to shift this over 4, and there's negative 4 on the x-axis. And I would draw it the same, right? But what else is happening? It's being expanded, right, by a half. It's being multiplied by a half. So instead of a slope of 1, it's going to be a slope of a half. So I'm going to go there, and there, and there, and that gets right about there. And so I'm going to say, goes out here and halfway, and there it is. There it is. So I could have said the parent function, f of x, is absolute value of x. Sound pretty cool, right? Well, so this is some sort of compression, and then it's going to be basically the same thing over here, right? Except, you know, we look at our parent function. Our f of x is going to be x squared, right? Well, what's happening? We're multiplying this by 2, right? And then we know what our parent function looks like to a certain extent. You know, let's see if we can put our marks in here. We go 1, 1, negative 1, 1, and then 2, and 2. So that's our parent function here. And it looks pretty thin, which is going to be kind of strange because we're also going to multiply it by a factor of 2. So besides the fact that we're going to drop it down 4 spaces, that's what it says, we're going to drop it down here. We're also going to narrow this little fella by a factor of 2. So, you know, if you think about x, y values there, 0 is negative 4. You put in a 1, 1 squared, 2 minus 4 is negative 2. So 1, negative 2, 2. We'd say 2. 2 squared is 4. Minus times 2 is 8. Minus 4. So we got 4. And so this shoots way up here. Right here. And right here. And then let's just do another one. We'll put in a 3. That's 8 times 2 is 16. 16 minus 4 is 12. So we can say that we go to here, just there. And probably almost right on top of it. And we see that it's a little bit narrower than what we were already being given. It's been compressed in or stretched, as it were, when we take a look at this. And that's basically what we're doing. We draw our parent function first, and then we take a look at what we've been given, and then fix it from there. I hope this works out for you. If you have any questions, please send me some messages, and I'll get to you shortly.